And you guys can still hear me okay at home? Okay. Okay. Oh, I didn't do that. Must have just dropped the connection. All right, guys, so we're going to look at page 1 right here, where it says solve for x. Now, the purpose of this packet of work is so that we really nail down those skills that we've been learning. And the card game will help you get faster at doing these problems, because there's a lot of reducing fractions, a lot of quick multiplications, and I wrote these problems so that they all work out very nicely. And so you should expect that the problems work out really nicely, okay? So let's start with number 1. 4 times 3x over 60 equals 5. What would be the first step here? Yes?
Get x by itself.
That is the goal. Would I multiply the 4 by the 3x or by the 60? Yeah, it always goes with the top. What's 4 times 3x?
4 times 3x.
So I write 12x over 60 equals 5. Okay? Now use your knowledge. So remember, 12, this is like queen, 12 and 60. What do they reduce down to? Right. You held up 5 fingers. What would I actually do though? Divide both the top and the bottom by not 5. Can't divide 12 by 5. By 12. So I'm going to cross out 12 and 60 and write 1 and 5. I've just reduced 12/60ths to 1/5. All right, so all I'm going to do is write x over 5 equals 5. Now what do I do?
Five over 1.
5 over 1.
X equals 1.
And I need to do that over here as well. Remember, we're going to always do the same thing on both sides. These cancel, leaving behind x equal to 5 times 5, which is 25. There it is. Yes, you are really good at this. You have that math. You see, she's able to just quickly tell me the products of these numbers. Guys, it's going to make your life so much easier. So that's what that card game is for. I guess I didn't mention this to this class. I went ahead and bought each of you a deck of cards. They will be here tomorrow, and I'm going to send you home with that deck of cards. And on the 4th page of this document, there's a little log that I've asked you and your parents to fill out. And I want you to practice playing that game with your parents or guardians 10 minutes a day for the rest of the week, once we get the deck of cards, okay? If you already have a deck of cards at home, you can go ahead and start tonight. All right, may I erase this? Okay. Let's do number 2. Oh, you're fine. Let me get you a packet here. Okay, number 2, x over 6 times 66 over x equals 11x. So you see 66, 6, and 11. You got it. You're thinking, okay, there's going to be something going on here with the multiples of 11. So let's just follow the breadcrumbs here. Well, I'm just going to go ahead and proceed to multiply across the top and the bottom. 66 and x multiply together to just be 66x. 6 times x is just 6x. Let's go ahead and rewrite equals 11x. Reduce this fraction. Yes, reduce this fraction.
Divide by 6.
Right. What's 66 divided by 6?
11.
11. Cancel, cancel. Make sure you write the cancel there. And then you put a little tiny 11 here and a 1 here. Now what about x over x? This is a math fact that we need to learn. X over x equals 1. So what it means in practice is I'm just going to cancel those x's. So now I have 11 equals 11x. Final step. Divide both sides by whatever's to the left of the x, which would be 11. Cancel, cancel. Right there. Now we have x equals 11 over 11, just like x over x. 11 over 11 equals 1. So the answer is 1. Folks, we had somebody get it up here. Jakayla, excellent work. She saw that up here. That's great. So far, so good. Guess what this is called? Algebra. This is algebra. What do you think of algebra?
Interesting.
Thank you. I'm glad you. I've always found it interesting. To me, if I know that a teacher or somebody, like not a computer, okay, has engineered the problem to be clever, and I already know that going in, I always think it's interesting to see what the little hidden tricks are that get me to something simple. When I first looked at this, I didn't see a 1 being the answer. But some people are good enough to see it. Can I erase this? Great. Well, we're doing great here. Let's do number 3. Home-based learners, are you doing okay? Can you see all this? Annie, can you see this okay? Good. All righty. Let's mute the mics. Thank you. All right. So what's my opening move here? Find the x. Yeah. There's actually many opening moves. Bethany, you get to decide. Do you want to solve for the x on the left or the right? Okay. So let's You want x to be on the right at the end? That's fine. Okay, so we'll do that, all right? So in that case, we need to go ahead and move this guy over here. How do I do that? Algebraically. Remember your inverse operations, okay? So this is positive 2x. If I want to move it, I'm going to subtract 2x from both sides. As long as I do the same thing on the left and the right, I stay in balance. Well, additive inverses are 0, so we just cross it out. Right, negative 4 equals. Now we actually perform this subtraction. What's 12x minus 2x? Yeah? Yes. Good job, Bethany. Good job, Jacayla. 10x, and then we just bring down the plus 36. Now, Bethany wants us to solve for x on the right, so we need to get rid of 36. So how do I do that? Subtract both sides. Yeah? What'd I say? Oh, I put the A in there. Sorry. So now I'm going to do minus 36 on both sides. Well, I've got positive and negative 36. Brain can turn off there. They just cancel out. And now we need to do this. You're going to get bigger on the negative because they're both negative. It's like adding. It's going to be negative 40. Negative 40 equals 10x. There's one more step. Well, two more steps. First, we're going to perform division somewhere. Then we're going to reduce a fraction, and we're going to be done. Divide 10 on both sides. Excellent. Divide both sides by 10. Now over here, these cancel. Cancel, cancel. And I've got x, just like Bethany wanted, x by itself. Now I need to reduce the fraction negative 40 over 10. One easy way is to just get rid of the zeros. Negative 4, thank you. Because the greatest common factor of negative 40 and 10 is 10. Okay? So if you wanted to show that step, you would cancel these out and put negative 4 over 1. Negative 4. Algebra. Okay, ready for number 4? Oh, we're still writing? Okay. Y'all are doing great. I'm glad I didn't make my final choices on who's going to win this first 6 weeks #1 prize, because there have been some folks come out of nowhere. Some new folks join us that are really shaking the competition up big time. Can I erase this? All right. If you guys want me to not erase it, make sure you say something. It's kind of like at a wedding where they say to the audience, speak now or forever hold your peace. Okay. I'm doing number 4. 7 open parentheses, 3x plus 7, close parentheses. I might need to move my camera, equals 49 plus 21x. And I'll go move that camera because I've written. I done written right off the screen. Let me just move it. Look at that. That's better. Well, now I need to use the D word. Distributive property. Okay. I've heard some interesting responses to that, but that's the correct response. How about 7 times 3x? 21x. Plus 7 times 7. 40. They're a football team. 49 equals 49 plus 21x. Now what? I should subtract 49. I'm going to do the limbo under the problem. Oh. Okay. I'm going to subtract 49 from the left or from the right? Does it matter? No. I'll just from the left. Minus 49. Minus 49. What do I get in each case? 0. Cancel, cancel. Now what? Now I've got 21x equals 21x. Subtract 21x from both sides. Let's see what happens. I feel like we're about to blow up math. Okay? What's 21x minus 21x? 0. Cancel, in other words. Leaving behind a 0. And then what's 21x minus 21x? 0. Now, does this look normal? No, this is something new. Okay. So when you find, now let me ask this question. This is important. Is this statement 0 equals 0 true or false? True. It's true. Okay? According to the identity property of equality, this is true. But there's no x. What you say is this problem is true for all real numbers. Yes, please, because this is what it will be on the STAR test. In other words, any value, we can say infinite, infinite, infinite solutions. Somebody says, well, how many values make this true? All of them make it true. Okay? So this is one of the strange cases you'll find. The other strange case, don't write this, just watch, is if you had something like 1 equals 0, and you ask the question, is this true? So in that case, you would write no solutions. Okay? So there's those two strange cases. And they'll probably give you one on the STAR test. But we'll practice it 1,000 times, so don't worry. Well, that was interesting. You know what? We have done very well today. Okay, guys, so we covered the first 4 problems here. And I want us to rest our brains. We played the card game. So make sure that you have completely filled out the front of your paper up here. If you don't know your lunch code, that's fine. And then I'm going to come around and pick them all up. Yes, ma'am.
Page 7 on the code.
I can certainly look it up, but let me wait till we're done recording so I don't like divulge confidential information. Can you flip it? I would like to make an announcement though. Over the weekend, we had to submit our nominations for Student of the Month. And I want you to know, guys, it's not easy. You have made this job hard. I've had some classes where it was really easy, not y'all, because it seems like everyone in here has something of extreme merit that I could nominate for Student of the Month. But I submitted a nomination for Becca. So let's give her a round of applause. Okay? Now, I nominated you. I have no idea if you'll win because every teacher in the building can nominate students. But thank you for everything that you do. It means a lot to me, okay? All right, guys, so that's all I have for class. Home-based learners, this packet is available in physical form up at the school at Miss Stanford's desk if you want a physical copy, okay? All right, well, at this time, we will conclude the lecture. And guys, thanks so much for being here. Appreciate it.